Now, does the consumer have sufficient information to make an educated precautionary selection of the phone? Say now about the peak spatial SAW, that is available to the user. But I guess more relevant, more important would be the average exposure. For example, of the cortex people would get. Here the information is not available. However, technology would be here to determine that phone dependent. So the information could be made available to people if there is a need for that. Exposure to base station is all these new models. It was shown that exposure limits in contradiction with basic limits. There's insufficient conservativeness of compliance testing procedure which are currently applied. Just I put that when we had the discussion this morning to show you where high exposure occurs. So high exposure occurs where partial body resonance are, which are at fingers, but also on penises. I don't want to say that explains the sperm effect found.
You don't want to say that?
No, I don't want to say that. This is the explanation for it. Revision of safety guidelines are therefore necessary, with revision of the general measurement standards as well as revision of the product standards are necessary to make everything bring everything in non-contradiction to each other. Control in biological research. They have been largely insufficient in the past, but with the availability of the new tools, excellent exposure control can be achieved. So the system must be optimized for the endpoints we are investigating in. This shows the largest facility of the largest experiments ever been set up, in which also Chris was involved. This is a large 2-year bioassay which will be conducted in Chicago, consisting of 21 reverberation chambers. Such a complicated exposure system became necessary because the target was to have free-roaming animals being exposed 20 hours a day for 2 years. And then also here, dosimetry is complex, so you need to have very good models. You need to be able to also post them like the humans in order to get reliable data in which you can enable the interpretation of the results. For that, you need to do the uncertainty analysis, which includes a lot of parameters. And if you also want to know how the exposure is varying over time, then you need to consider even more parameters. But all this is nowadays possible with the computer performance available and the models available. And for this, method and procedure have been developed and can be applied. Exposure assessment in epidemiology, as already discussed this morning by Darius. One problem is that technologies, usage and penetration are changing much faster than the required observation period. Exposure for specific tissue vary over several magnitudes that cannot be considered in the evaluation due to lack of information. Therefore, dosimetry is inherently insufficient for retrospective epidemiology, may be possible for prospective studies, and therefore epidemiological studies are limited to exposure assessment. I'm sure therefore we'll have some comments on these statements. So this brings me to the conclusion. Significant breakthroughs in simulation measurement tools in the last decade has been achieved. Dosimetric procedures have been developed for testing compliance with safety limits, and important in the discussion here for biomedical research. Reliable dosimetry can be achieved if the appropriate human anatomies and posture are evaluated, the appropriate simulation tools are applied, The simulation results are validated, anchored to real world by measurement, and with that the combined typical uncertain interval can be small, around 30%, and if you want to assess what the exposure is for 90% of the population, this also can be done nowadays. However, only a few studies until now meet these criteria. Mobile phone body-mounted transmitter. The average cortex and bone marrow exposure in children is significantly larger than in adults, but lower than the current safety guidelines. Incomplete information for precautionary selection by the consumer is available nowadays. Base station far-field exposure. Revision of safety standards are necessary due to inconsistencies, and revision of test procedures are necessary. Exposure control in biomedical research, insufficient in the past. However, we can do it now in a highly reliable way. And epidemiology, the pervasiveness and technology usage changes impair reliable exposure assessments, how we would, as an engineer, would like to have it for such studies. In the future, we need time domain sensor, didn't talk about that, and we need a better way to calibrate to get better and more accurate results. Simulation, as mentioned, we need acceleration because a lot of high resolution models need to be modeled in order to obtain reliable simulation. And in order to move in the direction of mechanism, we need also not only dielectric models, but we also need tissue models like nerve models, etc. In bioexperiments, we need studies targeting specific interaction mechanisms. I think I'm advocating here this. Darius advocated this. We need to know in the large parameter space we're looking at what may cause non-thermal effect. In exposure assessment, we need to inclusion of all anatomies, and in particular children, which haven't been done in the past, fetus exposure, etc. This concludes my presentation. Thank you for your attention.